Today we're going to talk about properties of logs. Alright, so the first thing we're going to talk about is change of base formula. And this came up a little bit already, because everybody wanted to know how to enter stuff into their calculator if it didn't have a base of 10. Go ahead and get out your calculator if you have it today. I'm not sure where I put mine. Okay, if you need to borrow one, they're up here. Okay, so the change of base formula is, you're going to have to use it when you don't have a base of 10 given, okay? So the calculator's base is the common base, and it's base 10. So that's what comes up every time you hit log in your calculator. If you want to change it, then you have to use this formula. So if you have log base a of x, then what you can do is put in your calculator log of x divided by the log of a. So what happens is now that base is base 10, okay? But you're changing the base. So right now, let's try it. If we had, sorry, log base 3 of 101. You can't enter that in your calculator unless you have a new updated system, and then you'll have like a little box pop up, and all you have to do is arrow over and change it. Okay, so you can do that if you have an updated system. If you don't, though, then you have to change the base. So in your calculator, you're going to type in log of 101 divided by the log of 3. What do you get? 2.326. Everybody agree with that? Okay. 4.2 what? Just 4.2. Okay. You might have to in your particular calculator. You can try it. Okay. So are we coming to consensus that it's 4.2 then?
Oh, yes.
Okay. Okay. This also will work if you type in the natural log of 101 divided by the natural log of 3. Try that. Did it work? Okay. So you can put in either one. You will get the same answer. So if I ask you to change the base, this is what you have to do. If you want to evaluate something now in your calculator that doesn't have a base of 10, this is how you're going to do it. Any questions? Okay. We're going to talk about some properties. So properties of logs. Keep in mind that these are also going to work for natural log. Okay, they'll be the same properties. Remember that logs are just exponents, right? It's a different way to write an exponent. And so because of that, these properties are going to follow the rules of exponents. Okay, so we're going to talk about kind of them simultaneously. All right, let's start out. This first one here is log, let's say base A of u times v. Okay, so what we're going to do today is we're going to expand and we're going to condense. All right, so right now this is condensed into one log. Anybody remember what the property is? If you have multiplication, what can you split it up into? Okay, yep, you can separate it into addition. Do you remember that?
No.
I think you should have last year expanded and condensed. Yeah, I think you did. You okay? Think about this. If you think about like x squared times x cubed, What do you do in order to condense those or combine those two? You add exponents, right? So multiplication is actually when you add exponents, and that's why multiplication goes with addition, okay? Because they're just like exponents. They follow the rules of exponents. So if you have log base A of u over v, okay, you normally don't put that in parentheses, but let's just look at it like that. What would happen here? Think about the rules of exponents. When you're dividing, what happens? You subtract. So it's going to be like log base A of u minus log base A of v. And that's because if you had like x to the 5th divided by x squared, then all you would do is x to the 5th minus 2. Okay, so division goes with subtraction. And then finally, the last property, log base A of u to the n. Okay, if you have a power, then what you can do is you can pull that power out front. Okay, so this n is actually going to get pulled out front and get multiplied by that log base A of u. And that's because if you think about if you have like x squared and it's raised to the 4th power, what do you do to those powers? You multiply them together, okay? So a power, which n was to the power, becomes multiplication. So that's how you can remember the properties, is they just go hand in hand with the properties of exponents. You ready to try some examples? Okay, so let's see. We'll call this example 1. We're going to expand the following using properties of logs. Okay, so when you see the words expand, that means you're going from one log into several, okay? Okay, so let's start out with log of 18. Okay, now log of 18. Seems like it's already expanded, right? It doesn't seem like there's really much you can do here. But the thing with 18 is that it's not a prime factor. So what you want to do is you want to use like prime factorization on this. You want to think about 18. So how can we represent 18 in terms of prime numbers? Everybody agree like 18 is like 2 times 9, right? So this is really like log of 2 times 3 times 3. Agree? Okay. So now if you have these numbers being multiplied, now it's like that property of log base A of uv, where we separated them into addition. So that's what's going on here. We have a bunch of things being multiplied, and we can separate them into addition. So we're going to get log of 2 plus the log of 3 plus the log of 3. You want to take it down to all the prime factors. Now, is this done? No, because these are like terms, aren't they? You can combine them. So final answer should give us log of 2 plus 2 times the log of 3. Now you could have also thought of this like log of 2 times 3 squared, right? Then that 3 squared, you would have pulled the 2 out front as well. So you would still end up with 2 times the log of 3. All right, so either way you want to think about it. But the point here is if you're given a number, you have to break it down to its prime factors, because things are being multiplied there. We just don't see it like that usually. Okay? How about this one? Log of 4/7. Okay, what is 4 in terms of prime factors? 2 and 2, like 2 squared. So couldn't I rewrite this as 2 squared over 7? And if you're dividing, what do you got to do to expand it? Change it to subtraction. So this is going to give me log of 2 squared minus log of 7. But this still isn't done because of this power right here. What can you do with the power? Just pull it out front. So we're going to get 2 log of 2 minus log of 7. You try this one. Log of 3x. What did you expand this into? Addition, subtraction, multiplication? Addition. So do you have log of 3 plus the log of x? Okay, good. Next one. How about natural log of the cube root of x? Okay, so let's think about the cube root. What's another way that we can represent the cube root? Yeah, the 1/3 power, right, is a fractional exponent. So this is the same as if I would have the natural log of x to the 1/3 power. So what do I do with that 1/3 power? We pull it out front. So I have 1/3 natural log of x. And now that's as far as I can go with this. Okay, so I still have a single logarithm, but I have to pull the exponent out front. Okay? How about this one? You try this one. Did you separate them into addition? So maybe you started with log of x squared plus the log of y. But we can take it further, right? Because that exponent has to be pulled out front. If you don't pull that out front, it's not simplified all the way. So we're going to have 2 log of x plus the log of y. All right, so we shouldn't have any exponents left in our final answer. How about the natural log of the cube root of a over b? Okay, so think about that cube root. Anytime you see a radical, you should think about the fractional exponent. So what's the cube root as in terms of a fractional exponent? The 1/3. So this is really like the natural log of a over b all to the 1/3 power, right? So if you have a fractional exponent or any exponent with raised to a fraction, then can't you just distribute that exponent to both of those pieces, right? So you really have like the natural log of a to the 1/3 over b to the 1/3, right? And then because it's division, how do you separate it? Good, into subtraction, so I get the natural log of a to the 1/3 minus the natural log of b to the 1/3. But then what do we have to do last? Pull those exponents out front. Now, it's going to be tempting to you to factor, because you love to do that, right? Once you get here, you'd love to take that 1/3 out. Don't do it, just leave it, okay? It's fine just like this. All right, just leave it as is. Okay? Questions? Everybody good? All right, continuing on, same directions. Going through the alphabet today. Log base b of xy cubed over z. You try this one. Did you get log base b of x plus 3 log base b of y minus log base b of z? Right? The addition is these two being multiplied here, right? We got to pull that 3 as the exponent out front. And then in the denominator, this is the division piece, this needs to get subtracted. Okay, so we're subtracting log base b of z. Any questions on that one? Okay, now I'm going to change it. So now, let's say we had log base b of x over y cubed times z. Okay, we're going to do this one together. Any thoughts on what's going on here? Everybody agree we're going to have some subtraction going on? How about some addition? Are we going to have any addition? So down here we're multiplying, right? This y cubed times z. This is being multiplied together, but the whole thing is in the denominator, right? So what we can do is we can start with our log base b of x, right? And we're going to subtract this piece, aren't we? Because it's in the denominator, right? And so division, you have to subtract. So I'm going to break this up into log base b of y cubed plus log base b of z. You see what I've done there? This represents the multiplication that's happening in the denominator. This subtraction represents the division that's going on here. Now, when you are expanding, you are no longer allowed to have any parentheses. Okay, so that's why we didn't want to factor out that 1/3. We want to get rid of the parentheses. So that means that I have to distribute this minus sign. So I have log base b of x minus log base b of y, but I'm going to pull the 3 out front. Is that okay? Because it's an exponent. Minus log base b of z. Do you see what just happened there? I have to distribute this. Now here's the trick. What happens is students will usually put the minus here, and then they'll put a plus here. Okay? You can't do that because both of these things are in the denominator. Make yourself a note. If you just follow this rule, whatever's in the denominator gets a minus sign, right? Because you're dividing by that. Even though this is having multiplication here, we can indicate that when we factor back out that negative. We'll see that multiplication happening in the denominator. So, whatever's in the numerator has a plus. Whatever's in the denominator gets a minus. Okay, so if you follow that, it's easier to remember. Okay? Let's look at one more and then we'll go the other way. So let's say we had natural log of x over the square root of x squared plus 1. Okay, now looking at this, do you agree I could write it as the natural log of x over x squared plus 1, that's a 1, raised to the 1/2 power? Okay, so here's the deal. This is a little tricky one because this x squared plus 1 is like all together, all right? So there's parentheses around that. So there has to stay parentheses around that. You can't get rid of those because that whole quantity is with the natural log. So you would write this one as the natural log of x minus 1/2 the natural log of x squared plus 1. So this is the only time you're allowed to have parentheses in your final answer. Okay, because you got to tell me that this entire piece is with that natural log there. Okay? Otherwise, it's read as 1/2 natural log of x squared, and then just add a 1. Okay? So the parentheses are important here. Any questions about expanding? Everybody okay with those 3 properties? There's just the 3 properties to know. They get more complicated. We're going to add more stuff, but if you follow the 3 properties, those rules are all you really need. Okay, now we're going to go the other way. So this is example 2, and we're going to condense into a single log using the properties of logs. Okay, so now we're going to have multiple logs to start out with, and we have to get it down to one single log, okay, or natural log. So let's say we have log base b of c plus log base b of d. So now you have to think the opposite way. When we see addition, we should multiply. When we see subtraction, we should divide. When we see some multiplication happening with some constant or coefficient out front, then we need to pull that over as an exponent. Okay? So looking at this, everybody agree that we should multiply. Okay, so this is just going to condense into log base b. Don't forget your base. Also, you have to have the same base. Like if this was log base b and this was log base x, you couldn't combine these. Okay, they have to have the same base. So we're going to get log base b of CD. All right, you don't need parentheses around that. How about 1/2 natural log of x? So that 1/2 out front, what is that? It's an exponent. So when you pull it over, we get the natural log of x to the 1/2. But you're not done yet, right? Because what is the 1/2 power? Square root. So we got to change that. Anytime you have a fractional exponent, we need to change it back into the radical form. Okay, so you got to take it a step further. So a lot of times students will stop here. You got to keep going. How about the natural log of x minus 1 minus the natural log of x minus 3. Notice you have parentheses around these pieces. Okay, so that was kind of like that one that we did, the very last one, where we have to keep those parentheses. So thinking about this, this is our sign here, the subtraction that we're looking at. It's the natural log minus this natural log. So how do you condense this? Division. So you have one natural log written out front, and then we're going to have x minus 1 divided by x minus 3. Here the parentheses don't matter anymore because it's already locked in when it's in the numerator and the denominator. Okay? If you put them, you're not wrong, but they're just not necessary. Okay? Okay, you try this one. Log of x minus 2 log of y. Yeah, Ryan. Yep, doesn't matter. It's fine. Did you change it to division? You only have one log written out front, right? So it's log of x divided by y squared. Okay, that 2 gets pulled over as an exponent, and then we divide. Moving on. No, because it's not a fraction. The only time you're going to change it into a radical is if you have a fractional exponent. Okay, so it's like I pull this 2 over, and then I'm good. Okay. All right. What letter was that? D. So this will be E. Okay, how about 3 natural log of x plus 2 natural log of y minus 4 natural log of z. So all of these numbers out front are exponents, correct? So it might be easier for you to pull them over as exponents first. So maybe it might be easier to look at natural log of x cubed plus the natural log of y squared minus the natural log of z to the 4th. Okay? So anything that has an addition sign is multiplication, right? And then anything that has a subtraction sign, that's being divided. So we're going to end up with the natural log of x cubed y squared over z to the 4th. Everybody agree with that? Make sure if you have multiple variables in that numerator that they end up in alphabetical order, okay? Now, what if we had this one? 2, let's do some brackets here. Natural log of x minus the natural log of x plus 1 minus the natural log of x minus 1. Okay, so this 2 out front is really being distributed to all 3 of those pieces, right? And if we distributed a 2 to all of these pieces here, wouldn't they really just become all of those exponents as a power of 2? So this is really like having natural log of x squared minus the natural log of x plus 1 squared, right? Minus the natural log of x minus 1 squared. kind of wish I wouldn't have written it like that. Oh well, I'll show you a different way in a second. Actually, can we just rewind? Can we just rewind? Rewind the tape. Pretend like we didn't distribute. Let's just pretend like we didn't distribute. You'll see why in a second. If we think about just the inside here, this minus and minus, what is that telling you? Isn't this kind of like saying the natural log of x divided by x plus 1 divided by x minus 1? Like if we read it as division in division. Agree with that? And so this division down here, isn't that the same as having the natural log of x over x plus 1 times 1 over x minus 1? Right? You can, whatever you're dividing by, you can multiply by the reciprocal. It's the same thing. So notice what happens here is you end up with the natural log of x over x plus 1 times x minus 1. Well, isn't that what I kind of told you that hint was at the beginning, right? Anything with a minus sign would end up in the denominator, right? And so we see that happening here. These both have a minus sign. They both end up in the denominator, okay? That's because you're creating this compound fraction which changes into the multiplication of the reciprocal, okay, ending up in the denominator. Now let's distribute the power, because do you notice here we have a difference of squares, right? So really we have the natural log of x over x squared minus 1. And then when we pull that 2 over, right, as our exponent, we have x squared over x squared minus 1 squared. This is a pretty big problem, okay? You want to look at that again? Kind of just talk that through one more time. So you can set it up as a compound fraction where you just continue the division down the line and you think about it like multiplying by the reciprocal. But actually, you don't really need these two steps, right? Like we could really get rid of these two steps if we just follow the rule that anything with a subtraction sign has to end up in the denominator, okay? So because those both had the subtraction to begin with, they end up in the denominator. You should recognize that that's a difference of squares when we go ahead and multiply that together, giving us the x squared minus 1. And then that 2 out front we can pull over as those exponents. Some of you are going to be able to go from here to here in one step, okay? Some of you might have to write out every single one of these steps. It just kind of depends on how you see it, okay? So you just take your time and follow the properties, all right? Okay, why don't you try this one? We have 2 more. Yeah?
So you don't want us to like distribute the denominator out with the square and so
No, no. Leave it like that. All right, so 2 more. I guess we're on G now. So you try this one. 4 and then brackets, natural log of z plus natural log of z plus 5 minus 2 natural log of z minus 5. let's start by combining the brackets. So did you maybe start with this so that you had the natural log of z times z plus 5? Okay, minus 2 times this natural log of z minus 5. Okay, now these numbers, right, are just exponents. So I'm going to apply that 4 here and here, and then this 2 here. So now I will have natural log of z to the 4th times z plus 5 to the 4th minus the natural log of z minus 5 squared. Okay, now you might have had a different approach. You might have distributed first, then pulled over the exponents. You might have done it in one shot. Okay, but we're just going to get to the end together. So now this subtraction is going to combine into division, and you should end up with, as a final answer, z to the 4th times z plus 5 to the 4th divided by z minus 5 squared. And that's it. Yes?
Is it wrong if you flip it for the numerator, if I had z plus 5 to the 4th first?
Nope, that's okay. Yep. These are interchangeable because it's multiplication. Okay? Everybody all right with that one? All right, last one. 3/2 natural log of 5t to the 6th minus 3/4 natural log of t to the 4th. I would like to deal with these exponents first. Is that okay? Okay, so I'm going to distribute this 3/2, and I'm going to pull over the 3/4. So I have the natural log of 5 to the 3/2. T to the, let's see, that's 18 divided by 2, so 9. Minus the natural log of 4 times 3/4 is going to give me 3, so t cubed. Okay, so now this subtraction is going to turn into division, right? And we're going to end up with the natural log of 5 to the 3/2, t to the 9th over t to the 3rd. But don't these simplify, right? T to the 9th over t cubed, you just can subtract those exponents, giving you t to the 6th. So now I have natural log of 5 to the 3/2 t to the 6th. But I got to deal with this 3/2, right? I can't leave it as 3/2. I have to think about what it means as a radical. So remember that the top number is the exponent of the base, and then the bottom number is the radical's root. So 5 to the 3/2 is really the square root of 5 cubed, correct? Well, what is the square root of 5 cubed? 5 root 5, right? You have to have 2 inside to take out 1. So we get 5 root 5. So final answer should be the natural log of 5 root 5, t to the 6th. Notice that in some of them, like in G, we could start here and we could expand back into here, okay? This one, we could not. We could not take this from here and end up here. Okay, there's too many steps on the in-between. Any questions on the expanding?